Well, aloha everyone, and welcome back to Anatomy 151 here at Chaminade University. Today we're going to be taking a look at the appendicular skeleton. This is going to be the second part of our skeletal system lecture series. It's going to be Unit 8 for those of you that are paying attention to where the files are located in Canvas. So we have 126 bones in the appendicular skeleton. And as you may know, we just went over the axial skeleton in our last lecture. So the axial skeleton is everything that's shown in blue, including the skull, the rib cage, and the vertebral column. The appendicular skeleton is going to be everything associated with movements. That's all of your long bones. It also includes your shoulders and your pelvis, right? Your pectoral your what we call girdles. So as appendages, the bones include the upper and lower limbs. That includes the girdles that attach them to the axial skeleton. Again, that's going to be your shoulders and your pelvis. The two pectoral girdles, those are shoulder girdles, are going to include a clavicle, that's your collarbone, and the scapula, that's your shoulder blade. The clavicle, again, that's the collarbone. It's going to be a little bit of S-shaped. The medial end is going to articulate with the manubrium of the sternum, right? So here's the sternum right here. And the lateral end, that's the acromial end, is going to articulate with the acromion of the scapula. The scapula is the shoulder blade. It's a flat bone located in the superior part of the posterior thorax, and it's located just between the second and seventh ribs. So it's going to span between the second and the seventh ribs. It's got a glenoid cavity, and that's the attachment point for the humerus, which is the upper arm bone. So here's the glenoid cavity, and that's going to be the region that's going to attach directly to the humerus. Some other things that you might need to take note of here. So here's the acromion, which is where the clavicle is going to be interacting, right? Here we have a region called the coracoid process. That's also then the glenoid cavity is back in here. Again, this is where we're going to be articulating with the top of the humerus. We have a superior angle and a superior border that are both going to be right next to the scapular notch. And we have this region here, the subscapular fossa, which is just going to be basically a large dent in the scapula. And then on the medial or the vertebral border, that's here. It's going to be along the medial edge. The inferior angle is going to be right at the juxtaposition of the lateral and the medial sides. So if we look at it from a posterior view, here's our superior angle and the superior border and the scapular notch, which you just saw here from the anterior view. But then we also have the supraspinous fossa here. This is going to be the spine of the scapula. The coracoid process we also saw here. Again, that's going to be where we're articulating directly with the clavicle. Additionally, from the posterior view, we see an infraspinous fossa here, and the medial vertebral border is going to be this side, which is then going to interact at that inferior angle with the lateral border. Here's a lateral axillary border there, axillary border there. All right, so the humerus is the arm bone, and that's going to articulate or interact with or line up with or fit with, however you want to say that, but articulate with the scapula in the proximal region. Basically, its rounded head fits directly into the glenoid cavity, and distally, it's going to interact with the radius and the ulna. The trochlea articulates with the ulna, and so the trochlea of the humerus, and the capitulum of the humerus is going to interact with the radius. So what does that look like? All right, so here we have the humerus. Okay, the humerus has the neck, right? Here's the anatomical neck. It has the tubercle. We have a greater tubercle and a lesser tubercle that are both sticking out here. Again, it's going to interact directly with the glenoid cavity here at the head. This is the surgical neck, so the anatomical neck is there. The surgical neck would be here. And then as we follow that down, again, this is the humerus. We have a deltoid region. Deltoid tuberosity region. And then this is the body, so the whole region, the shaft is considered the body. And then as we get down to the bottom, we have these fossa, right? And then they're going to end in these. So we have radial fossa and the coronoid fossa. And we also have what's called an epicondyle, which is a region that sticks off of the condyle. Here's the lateral epicondyle and the medial epicondyle. And these two are going to interact directly. So the medial epicondyle is going to be right next to the trochlea here. The trochlea interacts with the coronoid process of the ulna. And the capitulum, which is right next to the lateral epicondyle of the humerus, is going to interact with the head of the radius. Okay, that's what this looks like from the anterior view. The posterior view, we're going to see the same thing, except now we're looking again from the back. So here is the anatomical neck and the surgical neck, and the greater tubercle. You can only see the greater tubercle here. The lesser tubercle is only visible from the frontal view. And then as we follow down the deltoid tuberosity here, we have a radial groove. And that's going to run down to, this is the lateral and the medial epicondyles. So we have two epicondyles here at the end of the humerus. And the olecranon is right here, the olecranon fossa. And this is the olecranon. The olecranon actually interacts with the olecranon is actually part of the ulna. So the olecranon of the ulna is going to interact with the olecranon fossa. So if you're actually feeling your elbow bone all the way out, that's your ulna ending here at the olecranon, which is the region that you might think of as your actual elbow. The radius is also going to interact with the humerus here at the lateral epicondyle here through the capitulum. It's going to be the region of the capitulum. All right, so again, the ulna and the radius are the bones of the forearm, and we have regions of these bones called the olecranon and the ulna and the coronoid process of the radius, and they're going to, the olecranon and the coronoid process of the ulna are going to form what we call the trochlear notch, and that wraps around the trochlea of the humerus, and that makes up the entire elbow joint here. So it's going to, like as I mentioned, wrap around and make up what we call the elbow joint. The radius is located on the lateral side of the forearm, so the side that's closest to your thumb. So ulna, pinky, radius, thumb, and the articulation of the head of this region, the capitulum of the humerus, is going to interact with that region of the radius and with the ulna, and that allows the forearm to be able to rotate. So the head of the radius and the capitulum of the humerus and the ulna are all going to be at the same location, allowing the forearm to be able to turn or to rotate. Additionally, the radius and the ulna are held together by this intraosseous membrane. So these bones are actually held together by a membrane. Again, the humerus extends down. That's going to come down from the shoulder all the way down to what we call the elbow, right? The elbow here, we have the radial fossa and the coronoid fossa of the humerus. Those are going to be juxtaposed to the trochlea and the capitulum. The trochlea and the capitulum are going to be interacting directly with the head of the radius and the neck of the radius with the capitulum, and with the trochlea interacting here with the coronoid process of the ulna. Okay, and again, the ulna and the radius are held together by that interosseous membrane. And then if we go down to the wrist, the head of the ulna is going to interact directly with the styloid process of the radius. And then we're going to head directly into the carpals, of which there are 8. From the carpals, then we go to the metacarpals and then the phalanges. Alrighty. So continuing on, now we're looking at the elbow here itself. The elbow is going to be comprised of 3 bones, right? This is comprised of the humerus. Here's the radius, and also the ulnar. And the ulna is going to have a region that's going to interact with the medial epicondyle of the humerus. Okay, and that's called the olecranon. So this region here is called the olecranon, and the olecranon is going to interact directly with the medial epicondyle of the humerus to allow for what we call the elbow region, right? But also connected in here is the radius. The head of the radius is going to be interacting with the capitulum, and that whole thing is going to form your elbow. Right, again, intraosseous membrane connecting the two of them. If we're looking at the proximal end of the ulna, so the region of the ulna that's going to be interacting here with the humerus. Again, this is the olecranon and the trochlear notch. That's going to interact with the trochlea right there and the medial epicondyle of the humerus. Here's the coronoid process and the radial notch, which is going, or the radius is going to line up as well, and then the ulnar tuberosity. Okay, if we are looking from an inferior view of the distal ends of the radius and the ulna, so again, this is where we're going to be. So instead of having the proximal end, which is what's going to interact with the elbow, this is going to be the distal end. It's going to be interacting with the wrist. So again, the radius and the ulna coming down from the elbow to the wrist, interosseous membrane connection them. And we have this region here. It's articulation for the scaphoid bone. And then we also have articulation for lunate. And here's the ulnar notch, which is going to be where the ulna and the radius are going to interact with each other. So the ulnar notch is going to be on the radius, allowing for the head of the ulna to interact here. The ulna also has styloid processes that are going to stick off here, and then so does the radius as well. All right, so the wrist bones are called the carpal bones. You may have heard of carpal tunnel syndrome. There's 8 small bones that are connected by multiple ligaments and are arranged in 2 rows of 4. So the proximal row includes the scaphoid, the lunate, the triquetrium, and the pisiform, and that articulates with the distal radius and with the ulna. And the distal row, which is going to interculate with the metacarpals, is the trapezium, the trapezoid, the capitate, and the hamate. And when I say metacarpals, I just mean that next series of hand bones that are going to be between the wrist bones and the phalanges. So those 5 metacarpals are the hand bones that make up the palm and the back of the hand. They're numbered 1 through 5, right? And that starts with the thumb. So 1 is thumb and 5 is pinky. And their bases articulate with the distal carpals, right? So that's going to interact with your wrist on the distal region. And then on the proximal region, they're going to articulate with the phalanges. I apologize. I said that backwards. They articulate with the distal carpals on their proximal region, and they articulate with the proximal phalanges on their carpal region, just to be clear. So the phalanges are the bones of the digits of your fingers, right? There's 14 total, and that's because your thumb only has 2, while the other 4 contain 3. So the thumb only has the proximal and the distal, and the other 4 have the proximal, the middle, and the distal. And that looks like this. Okay, the radius and the ulna, again, they're interacting together at the carpal region. In the carpal, we have 4 on top and 4 on bottom. The 4 on top go in this order: scaphoid, right? Lunate, pisiform, triquetium. And then the next set is going to be the trapezium, the capitate, the trapezoid, and the hamate. Right? And then that's going to lead us directly to the metacarpals. Again, 1 with the thumb, 5 with the pinky. And those are going to be the palm, basically, and the back of the hand. And they're going to attach to the digits. The thumb has 2 bones, and the index, middle, ring, and little finger all have 3 bones. Here's sesamoid bones. These are specialty shaped bones. You only have a couple sesamoid bones in your body, including the kneecap. So here's another example of a sesamoid bone. All right, so looking at the posterior view, so I was looking at it from the front, from the palm. Now we're looking at the posterior view from the back. So this is the ulna and the radius coming down into the carpals. Again, we have 4 of them on the top and 4 of them on the bottom. From this side, it's going to be triquetium. We cannot see the pisiform from this angle, then lunate, then scaphoid. And then we're going to have from this direction the hamate, the capitate, trapezium, and the trapezoid. I'm sorry, trapezoid and trapezium, yes. And then we have these 5 here are the metacarpals, 1 thumb, 5 pinky. Again, for the phalanges, we have 2 bones for the thumb and 3 for each of the other fingers. So just proximal and distal on the thumb, proximal, middle, and distal for the other 3. All right, so let's jump now to the legs. We're going to start with the pelvic hip girdle. And that's going to be where we're comprised of 2 hip bones. Those are known as the os coxa and the coxal bones, and they articulate with the sacrum. They articulate in the back, so posteriorly with the sacrum. As you may remember, the sacrum and the coccyx were originally separate bones, but then so the sacrum comprised of 5 and the coccyx comprised of 4, and then they fused together to make just the sacrum and the coccyx respectively. So the sacrum interacts directly with the pelvic girdle. And the hip bones are made up of 3 individual bones. That's the ilium, the ischium, and the pubis, or the pubic bones. And they're going to articulate in the front at the pubic bones at a region called the pubic symphysis. And there's a little bit of fibrocartilage between these 2 bones. And they are all going to fuse into 1 hip bone by the age of 23. So just like you heard about the sacrum and the coccyx fusing between 20 and 30, the hip bones are also all fusing together by age 23. So by the time you are 30 years old, all of these bones have become 1, even though they were originally separate bones when you were younger. All right, so here's the pelvic hip girdle. This is what I'm talking about. So if we look at the posterior view, it's showing here the little parts of the hip bone, right? Here is the ilium, the superior being the top part, right? Posterior, superior and inferior, posterior and anterior. So here's the ilium, the ischium, and the pubis. And if we look at the lines or the delineations within these regions of the bone, the ilium has several markers that we want to take a look at. First, we have these gluteal lines, the anterior, inferior, and posterior gluteal lines. And these are where the gluteus maximus muscles are going to be, these are going to be sites of attachment, and they're going to run along these ridges. We have the iliac crest as well, just at the top of the ilium, obviously. This region is called the ala region. And then the anterior superior iliac spine, anterior inferior iliac spine. So this is the anterior iliac spine, top and bottom, basically. This region is the bottom of the ilium. From the back, we have the posterior superior and the posterior inferior iliac spine. We have the greater sciatic notch. This is where sciatic nerve is going to run right along this. And then the ischium has the body, the ischial spine, the lesser sciatic notch, the ischial tuberosity, and the ramus of ischium. The pubis bone is going to, we actually also have the acetibular notch here, which is where the acetibulum is going to sit. This is the acetibulum here. And then here we have the superiorus ramus of the pubic. So here's our pubis bone. And then also have the pubis tubercle, or a little protrusion region. And then this is the obturator foramen, or a large hole in the region. Now, the head of the femur articulates with the acetibulum. So let me go backwards. Here's the acetibulum. You can see how the head of the femur would fit right on in there, right? So the head of the femur, or the thigh bone, is going to be basically a ball and socket joint, with the ball of the femur interacting with the socket in the hip. And the acetibulum is comprised of all parts. The parts of all three of the bones that make up the hip bone. So even though it appears to be just one divot, it's actually comprised of three separate bones. So all of these bones are going to contribute to the acetibulum, which is again the region where we're articulating with the femur or the thigh bone. All right, so the pelvis is divided into superior region and an inferior portion. So superior would be the top, obviously inferior would be the bottom. And so if we're looking at it from the top, this is the superior portion. It's got the pelvic brim. And it's separating the top and the bottom right here at this pelvic brim. It's basically where the abdomen is going to meet the pelvic cavity. Now again, here's the sacrum. The sacrum is going to interact directly with these hip bones here. Some other pelvic brim landmarks are the sacral promontory here at the edge of the sacrum. And that's going to go all the way to the pubic crest, which aligns here at the pubic symphysis. Then another thing is the arcuate line, which is also part of the pelvic brim. All right, so we have the false pelvis and the true pelvis. The area of the pelvis that's actually superior to the pelvic brim, so above the pelvic brim, is known as false. And the area below or inferior is known as the true pelvis or the less pelvis. So this region is called the false pelvis, and it's everything that's above that pelvic brim. Again, everything below that pelvic brim here is considered the true or lesser pelvis. Down here, and this here is the coccyx, here's the sacrum, the sacral canal, and the pubic symphysis in the front. All right, now there are many differences between the bones of these regions, right? And the reason that they call them the false and the true pelvis is because the true pelvis is actually supporting weight, and the false pelvis is going to be kind of more structural, right? So again, here's the false pelvis, everything above that brim, everything below it is the true pelvis. All right, we have differences between the male and female pelvis as well. So pelvis being the plural of pelvis, so two pelvis, pelvis. Interesting. So they differ in multiple ways. The first is that the male felt pelvis is usually larger and heavier in terms of bone weight and density. And a lot of these differences are mainly associated with the requirements for a female in terms of pregnancy and childbirth. So the female pelvis is going to be wider and more shallow than that of the male. Right, so you can see the female wider and more shallow, and that's because we're going to have to deliver a child through this canal, whereas a male is not expected to do so. So they're going to have a more thinner and more narrow pelvis. Additionally, they also are going to have differences in the pubic arch. So the pubic arch on a female is going to be greater than a 90-degree angle, and on a male is going to be less than a 90-degree angle. So that's one of the quick and dirty ways that you can tell by looking at a skeleton if you're dealing with a male or a female skeleton, is by the angle there of that pubic arch. The other difference is that the shape of the acetibulum, so where the hips actually interact with the femur, is going to be a little bit different. So for the female, the acetibulum is small and faces anteriorly. And for the male, it's larger and it faces laterally. So instead of facing forward, it faces laterally. So it's just a little bit of a difference in where the hip actually connects to the femur. All right, so here's some other points of comparison for the female and the male in the pelvis. And this is something that is all fair game for the exam. Just a couple questions will be XYZ finds this bone in a archaeological site and wants to determine if it's male or female, right? And one of the first things you look at, of course, would be that pelvic notch that I talked, the pubic arch, I apologize, and determining the angle of that, but also the size of the also the size here of the pelvic brim, whether it's wide, whether it's shallow, etc., where the acetibulum interacts, etc. We also can look at the iliac crest and the ilium. You can see the iliac crest is actually going to be a lot wider and a little not as elongated as the male. Here they're going to be a little bit taller and a little bit less wide. The greater sciatic notch is actually going to be a little bit smaller in the male than in the female as well. Oh, wow, we would just jump way ahead. Sorry about that. All right, so let's talk about some lower limb extremities. So we're going from the pelvis, now we're going to extend down into the femur. The femur is the thigh bone. It is the longest bone, the heaviest bone, and the strongest bone in the body. It has a proximal end, which interacts with the acetibulum of the hip bone. It looks like a head. And it also has a distal end that articulates with the tibia, which is the shin bone, and the patella, right, with the knee joint. All right, so what does that look like? Here's the greater trochanter. Again, the trochanter is only found on a femur. So if you hear the word trochanter, you're definitely talking about a femur bone. And the trochanter is going to be right next to the head, separated obviously by the neck. And the head is where it's going to enter into the acetibulum, right, which is going to be in the hip socket. Here we have the trochanteric line, the lesser trochanter. So we have a greater and a lesser trochanter. And then this is the body of the femur itself. Right? From the posterior view of a femur, we have this linea aspera, which is just going to run along the back side. And then we also have the gluteal tuberosity that is going to allow for the attachment of, or one of many attachment sites for the gluteus maximus muscles. All right, so if we head down from the body of the femur, we're going to interact with the lateral and medial epicondyle, right? Lateral outside, medial inside. Epicondyle just means a condyle that's going to have like a little protrusion. The epicondyle is going to reach down into the lateral and medial condyles, which are going to interact with the tibia. All right, they're also going to interact with the patella, which is your kneecap. So obviously we're looking from the front because we can see the patella here. The tibia is going to interact with the fibula. So the fibula. So the tibia and the fibula are both going to interact here at the knee joint, but just to be clear, the fibula only interacts with the tibia here. It does not interact directly with the femur. All right, so from the posterior view, femur coming down with the linea aspera leading into the lateral and medial epicondyle. And then from there, we end up with, this is an intercondylar fossa, so a little divot in between the medial and the lateral condyle. So the epicondyle leads into the condyles. There's an intercondylar fossa. And then that's going to interact directly with the tibia. Again, the tibia is going to also interact with the fibula, which does not interact directly with the femur itself. All right, so the patella, that's a kneecap, obviously. It's a little triangular bone, and it's going to develop in the quadriceps tendon and articulate with the femur on the posterior surface. So you can see here articular facet for the lateral femoral condyle, articular facet for the medial femoral condyle. So there's going to be an interaction there for both the lateral and the medial femoral condyles. This is the back view, right? The posterior view of the patella. As we're following down, the leg bones are, there's two of them. The tibia is the shin bone, which runs in the front, and the fibula runs along the outside of that. The tibia's proximal end interacts directly with the femur, so it articulates with the femur, and the distal end articulates with the talus bone, which is found in the ankle. And the tibial tuberosity is a region on the anterior surface that is the point of attachment for the patellar ligament, or the ligament that attaches the kneecap. All right, so here's what that looks like. Here's the tibia. Again, the tibia is the larger of the two. It connects directly with the femur. It also has an attachment point for the kneecap as well. And then it also attached down here at the talus, which is the top of the ankle. The fibula attaches at the top to the tibia, but at the bottom, it attaches at the lateral medialis, at the lateral malleolus, at the talus region. So although it attaches only at the tibia in the knee, it actually does attach to the ankle. All right, so we're coming down the femur. Again, we have those condyles. We have the medial and the lateral condyles, and those are going to attach directly to the tibia. Right? The tibia has an interosseous membrane that connects it to the fibula, similar to what the radius and the ulna experience. As we go down the tibia, for the anterior view, we have this border crest, so a crest in the front. In the back, we don't really see anything that's like that. We do have a little bit of a crest here, but there's nothing that's written out about it. And then as we come down, that's going to interact with the talus here at the ankle bone. The fibula is going to interact both with the tibia and the lateral malleus there at the talus region. All right, so sorry, the tarsus region. The tarsus region is the ankle region, and there's 7 tarsal bones. So just like we had 8 carpal bones, we have 7 tarsal bones, so they're going to be very similar. We have the talus, calcaneus, that's the heel, and the navicular, and 3 cuneiform with a medial, intermediate, and lateral cuneiform, and the cuboid. And then that's going to lead us into the metatarsus. So just like we had carpals, metacarpals, and phalanges, now we have tarsus, metatarsus, and phalanges, or tarsal bones, metatarsal bones, and phalanges. So there's 5 metatarsal bones, just like the metacarpals, numbered 1 through 5, starting with the big toe. So just like we start with our thumb for 1, and then with our pinky, we're going to start with our big toe as 1, and our littlest toe as 5. And they're going to comprise the sole and dorsal surface of the foot. And the proximal end of the metatarsals are going to interact with or articulate with the cuneiform bones and the cuboid. And the distal ends are going to articulate with our toes, or the proximal phalanges. So the phalanges are arranged just like those of the hand. The big toe has two, the proximal and the distal phalanx, and the others have proximal, middle, and distal phalanx, just like you would expect from, say, the fingers. All right, so what does this look like? So now we have the tarsals. Again, that's the ankle bones. Those attach to the metatarsals and into the phalanges, right? So the talus is here, which is what's going to actually be articulating with the tibia, right? So that's then going to go into the navicular. And then underneath that, we have the third, second, and first cuneiform and the cuboid. All right. We then have 1 through 5 of the metatarsals, 1, 2, 3, 4, 5, 1 being connected to the big toe, 5 connected to the pinky toe. And each of those have a base, a shaft, and a head. Additionally, we have the phalanges, which are going to have 2 for the large toe, right? The proximal and the distal. And then we have proximal, middle, and distal for the other ones. Now, for the great toe, that distal bone is actually called the great toe. That's called the hallux bone. So the large part of your big toe is called the hallux, the distal bone of that phalange. So a mnemonic for the tarsals is tall centers never take shots from corners. I guess it's a basketball analogy, but that helps you remember talus, calcaneus, navicular, third, second, first, and cuboid. Third, second, first, cuneiform, and cuboid. All right, so let's talk a little bit about the foot. So we have arches in the foot that are supported by ligaments and tendons, and the purpose of the arches is to allow support of the weight of the body and also to provide leverage while walking around and distribution of the body's weight, basically. We have 2 arches, the longitudinal arch, which is made up of a medial and a lateral portion. So we have the medial longitudinal arch and the lateral longitudinal arch, and we also have the transverse arch. So what does that look like? So here's a longitudinal arch. The longitudinal arch has the medial part, has the medial part and the lateral part. And then we also here have the transverse arch, which goes all the way across. So the longitudinal arch goes basically from heel to toe. We have the medial part, which is going to be in the middle, and the lateral part, which is on the outside, and then the transverse arch, which basically goes from the inside to the outside of your foot. All right, so here's the fibula. This is the lateral malleus, which is interacting directly here with the talus region, right? So here's the cuboid bone. Calcaneus is the heel bone connected to the talus bone. From there, we're going to go to navicular, cuboid, the cuneiforms, right? First, second, and third, and then the metatarsals, and then the phalanges. All right, so what is the point of the skeletal system? The skeletal system is very important in playing a role in homeostasis, both directly and indirectly. So the skeletal system is very important in the proper functioning of all of these systems. All right, I appreciate your taking the time today to go over the appendicular skeleton, and aloha and happy studying.